Problem on free fall. From a 65-meter high building, a pebble was thrown vertically upward with a speed of 11.0 meters per second. Neglect air resistance. What is the maximum height reached by the pebble from its original position? Letter B, what is the total distance covered by the pebble? And letter C, how long is the pebble airborne? Okay, so we will start our problem by writing the given. So the pebble was released from top of a 65-meter high building. So that's our delta y. Okay, then the initial speed is 11.0 meters per second, and the instantaneous velocity at maximum height is 0 meters per second. Now we have to look for maximum height reached by the pebble. So our required is delta y max. Okay, so let's think of the equation that we will be using for this problem. Alright, so that's correct. So vf squared equals v initial squared plus 2g delta y. Okay, so to start our solution, our vf or v final to get the delta y max is 0 equals v initial is 11 squared. I will disregard the SF and units for now, plus 2 times g, which is negative 9.8, and we have your delta y. So we have one equation, one unknown, so you can compute for delta y now. So we have 121 minus 19.6 delta y equals 0. So one equation, one unknown, our delta y is equal to 6.17 meters. Okay, so this is our answer for the first question. What is the maximum height reached by the pebble from its original position? Now, for the second question, what is the total distance covered by the pebble? So we know that the pebble traveled 6.17 meters to reach maximum height, then another 6.17 meters to return to its position, then it covered the height of the building, which is 65 meters. We just add all the distances. The total distance is 77.3 meters. So this is our answer to our second question. This is the continuation of the previous problem on pebble. So let's write again our given. So you have a building which is 65-meter high and a pebble which has an initial velocity of 11.0 meters per second. Okay, now from the concept that we have discussed in class, we have to identify some given which is not mentioned in the problem. So first, our instantaneous velocity here is 0. At maximum height, the instantaneous velocity is always 0. And since here, they're of the same position, but opposite in direction, this is 11 meters per second going up, and this is now 11 meters per second going down, but the direction should be opposite. So 11 meters per second, then same position, negative 11 meters per second. Okay, so the question is, how long is the pebble airborne? Okay, so we need the total time. So if only we know time up and time down, we can compute for the total time. Okay, so here you are given the initial velocity and final velocity. From the equation Vf equals V initial plus Gt, you can already get T. Okay, so here our final velocity is the maximum height. So T up. So the object is going up, the pebble is going up. So this is our final velocity. So 0 equals V initial, which is 11. I will disregard the units and significant figures for now. plus G is negative 9.8 times T. Okay, so you have one equation, one unknown. You can compute for time, and time up is equal to 1.12 seconds. Okay, actually we can apply the same equation to compute for time down. Okay, however, we have a problem. We don't have the final velocity before impact, but we can compute for that using the other information. So we have delta y, which is 65 meters. So since the object is going down, we will consider this to be negative. Then we have a negative 11 as our initial velocity. Again, we can compute for final velocity because we are given delta y, which is negative 65 meters, and initial velocity of negative 11. So using this equation, Vf squared equals V initial squared plus 2g delta y, we can compute for V final. So this time, the object is going down. So our V final is here. So V final squared is what we're looking for. V initial is negative 11 squared plus 2 times negative 9.8 times negative 65. Okay, so our Vf squared is equal to what? Our Vf squared is 1,395 meters squared per second squared. Okay, so we have two values of our Vf, a positive 1 and a negative 1. So what is the sign that we will take? The negative 1, because our object is approaching the reference point or is going downward. So our velocity at before impact is 37.3 meters per second. Okay, so using the same formula, we can compute for time down. Okay, so Vf equal, okay, so using Vf equals V initial plus GT. This time our Vf is negative 37.3. Our initial velocity from the maximum height is 0 plus negative 9.8 t. Okay, so we can now compute for t. So t down, t equals 37. Our t down is 3.81 seconds. Okay, so we can now compute for total time. So that's simply 1.12 plus 3.81. So the total time would be 1.12 plus 3.81. Okay, so our total time is 4.93 seconds.